Alright, so we're going to talk about the relative arrival time technique, RATT, the RATT. For us, this will be a qualitative technique. It's going to be our start of talking about sizing, flaw sizing. And this is something that we can use to indicate the relative flaw height, if it's a shallow flaw, or a deep flaw, or extremely deep flaw. And before we look at this on the UT machine, let's take a look at our notched cal block. This is our 300 thick notched block. 300 thick. We're going to set it up with the notches down. And we're going to come in with the 45 and look at each notch. And we're going to see two things on each one. We're going to see a corner trap signal from the corner. And we're going to see, which will be very loud, because it acts like a prism to send the sound back. And we're going to get a small signal back from the tip. And why don't I go ahead and illustrate that a little bit like this. When you've got a corner down here coming from a 45, all the sound will come back like out of a prism at you. So there's a lot of sound coming back. As opposed to the sound coming back from the tip, what's happening there is when some sound comes and hits an edge like that, there'll be a little bit of diffracted sound that radiates out in all directions. And it's very low amplitude, and some of that sound will come back. Alright, so we're going to come in here with a 45 and look at each of these. And if the crack is shallow, relatively shallow, the distance from the 45 search unit to the corner, or the distance to the tip, there's not too much difference between those two distances, so they'll be very close together in time. But if it's extremely deep, there's a big difference in time between the time it takes to go to the corner and the time it takes to go to a tip, if it's extremely deep. So we're going to look at those two signals, the corner and the tip, and they'll walk with each other. They'll have the corner, and then you can push up to watch the tip. And you should see a typical type of walk on there. And we'll use this as a qualitative technique to tell if something is relatively shallow or relatively deep. All right, here we are back at our flaw detector. So now I want to establish a routine that each time I go to do something, I'm going to go through a series of 4 steps. I'm going to recall the cal, check the cal, set the gain, and then go to work. Alright, so let's go ahead and recall the cal. Go to the File menu, Open, selected 45, Open, Contents, Recall. I've recalled the 45. Okay, recall the cal, check the cal. I'm going to take my 1/2-inch block and look at the 4 side drill holes. There's the 1 hole right there. And when I peek up on it, 1 is near 1. Here's the 200 deep side drill hole. Oscillate, back and forth. Oscillate. And the 2 is near 2. Here's the 300 deep side drill hole. The 3 is near 3. Here's the 400. And the 4 is near 4. Alright, recall the cal, check the cal. We just checked the cal, it looks good. Now we're going to set the gain. So whichever side drill hole is closest in depth to the thickness of what we're going to be working on, we'll use that hole to set the gain. So we're going to be working with the notched block, 300 thick. So I'll go to the 300 deep side drill hole, and I want to bring that signal to about 50% screen height, and that's where I normally am anyway. So I'm going to go ahead and set that as a reference dB. And reference dB is set. So this is where I want to be almost all the time at this gain setting. Alright, so let's go ahead and look at the notches. We can start by looking at the 150 notch. The flaw height on that notch is 150. Because it's 300 thick, the depth to the tip is also 150. And there's the corner trap signal right about at 300 deep. All the corner trap signals on all these notches, they're all 300 deep because that's where the corner is, right at the ID. So there's our corner trap signal. We can push up now, and there's our tip signal. Much lower amplitude than the corner. Corner, tip, corner, tip, corner, tip. All right, so let's peek up that tip signal, and if we want to put it in the gate to read it, we could add 6 dB now. 147, yeah, all right, 150 deep, good. All right, so let's, this is the RATT, the RATT, the relative arrival time technique. Let's look at some of the others. So here's the 60 thou deep notch, and the tip signal is very close to the corner. The two shallower ones, the 30 thou notch, that's hard to even see because I have a 5 meg here. I don't have that enough resolution to reliably pick that tip out of there. Here's the 10 thou notch. Not enough resolution to separate the corner from the tip. Okay, 10 thou, 30 thou, 60 thou. Now we can start to see that tip signal pretty clearly. And it's very close to the corner. 30, 90. Now we're getting more separation between the two. The relative arrival time technique is more separated. Here's the 120. Relatively speaking, the space between them is a little bigger. Here's the 150. Again, the space is a little bigger. Here's the 180. The space is a little bigger. Here's the 210. So the relative arrival time technique between the corner trap and the tip signal can be used in a qualitative sense to say that when those two signals are very close together, it's a relatively shallow flaw. When those two signals have a fairly large amount of separation between them, it's a relatively deep flaw. We should also be observing the walk of these signals. By the walk, I mean the echodynamic, the shape that it paints on the screen. This is a typical walk for a 45. All right, very good. Thank you.